Imagine stepping into a machine, pressing a few buttons, and suddenly feeling the world around you blur. A rush of wind, a strange tingling sensation, and then, bam, you find yourself standing in ancient Egypt, watching workers haul massive limestone blocks to build the pyramids. Or perhaps you've been catapulted 1,000 years into the future, surrounded by dazzling skyscrapers and technology beyond your wildest imagination. The idea of time travel has fascinated humanity for centuries, fueling countless books, movies, and theories. But could it ever be real? Science has a lot to say about it, and the answers might surprise you. To understand time travel, we first need to understand time itself. We experience time as a constant, ticking forward second by second, never slowing or stopping. But in reality, time is much more flexible than it seems. Thanks to Albert Einstein and his groundbreaking theory of relativity, we know that time is not fixed. It can stretch and shrink depending on speed and gravity. This is called time dilation, and it has already been proven by scientists using high-speed particles and precise atomic clocks. The faster you move, the slower time passes. For you compared to someone standing still. If an astronaut were to travel close to the speed of light and return to Earth, they might have only aged a few years while decades had passed for those they left behind. This means that, in a way, traveling into the future is theoretically possible. But what about going back in time? That's where things get even trickier. One of the most famous concepts of time travel comes from the idea of wormholes, shortcuts in the fabric of space-time. Imagine space-time as a giant sheet of paper. If you fold that paper so that two distant points touch, a wormhole could, in theory, connect them, allowing for almost instantaneous travel between them. Some scientists believe that if a wormhole could be stabilized, it might allow for travel not just through space, but also through time. The problem? Wormholes, if they exist at all, are incredibly unstable, and any attempt to pass through one could cause it to collapse instantly. Not to mention, we have no idea how to actually create one. Another mind-bending theory suggests that time travel to the past could be possible through something called closed time-like curves. In simple terms, these are theoretical loops in space-time that would allow an object to return to its own past. However, this brings up a whole new set of problems, including the infamous grandfather paradox. This paradox asks, what happens if you travel back in time and accidentally prevent your own grandfather from meeting your grandmother? If that happens, you would never be born. So how could you have traveled back in time in the first place? Some scientists think that the universe might prevent these kinds of paradoxes from happening, either by making time travel impossible or by ensuring events always play out in a way that avoids contradictions. Others propose the idea of parallel universes, where every action creates a new branch of reality, meaning that if you went back and changed something, you would simply create an alternate timeline rather than altering your own past. Even though time travel remains theoretical, real science has already given us glimpses of its possibilities. GPS satellites, for example, experience tiny amounts of time dilation every day because they orbit Earth at high speeds. Scientists have also conducted experiments with tiny particles called muons, which decay slower when moving at near-light speeds, essentially proving that high-speed travel can affect time. This concept has even made its way into pop culture, with movies like Interstellar and Back to the Future using relativity and paradoxes as key plot points, showing just how deeply these ideas have captured our imagination. While we may not have a time machine in our garages anytime soon, the science behind time travel continues to push the boundaries of what we understand about the universe. Perhaps someday, we'll find a way to harness these strange effects and make our dreams of journeying through time a reality. Until then, the mystery of time remains one of the most exciting frontiers in physics, leaving us to wonder, what if?